Page 684, lesson 11.4 is on adding and subtracting rational expressions. So rational expressions, we're going to have some fractions that we're going to be adding and subtracting together. So just like we've done with adding and subtracting fractions, we have to have a common denominator. So if you look at problem 1, this is the simplest problem we will see. The denominators are already the same. The denominators are the same. We can just add the numerators, keep the denominator, and then at the end reduce if possible. So you can see they just added those two numerators together. So 4 plus 7 is 11, and it's 11 over 3y. We can't reduce that at all, so that would be our answer for part A. Part B, denominators are the same as well. Once again, the numerators happen to be like terms, so we can combine those together. So that's like 3x plus 1x, which is 4x. So we have 4x over x minus 2. So let's look at the got it 1, and they're asking what this sum is. So once again, the denominators are the same, so we are adding, so we can just add our numerators together. So 2a plus 3a is 5a, denominator stays the same, and remember we've got a force field around the denominator there. Don't try to cancel a's because those are not factors in the denominator. You look at problem 2, talks about how we can subtract expressions that have the same denominator. So problem 2, they're saying what is the difference of these. So with the difference, what I like to do is I would probably just go off that original expression and put parentheses around the numerator, and then I would probably just say let's go ahead and add the opposite. You know, technically you don't even have to put the parentheses in the numerator, but if that helps you to think about how we would have probably done that previously. And then at that point, now that you've added the opposite, just like we've done with adding integers before, or subtracting integers, once you change it to an addition problem, it's just like what we've done with addition. So now it's just like what we've done in the previous examples. You combine your like terms together and you'll get this answer. One thing to watch for, which happens to work on this problem, if you'll notice on this, the denominator actually is a trinomial with a squared term and an x term and a constant, and that actually factors. So it factors, and I would probably again put the numerator in parentheses, and then at that point the 3x plus 2's can actually cancel out. If you want to think about putting a 1 in front of that, so you can say you still have a numerator left, and then this would be your answer. And again, if you want to put parentheses around your denominator, you can do that. So if we look at the got it, 2a is pretty straightforward there. Would just be adding the opposite. That'd be negative 5 over z plus 3. That's all there is to that one. If you look at part B, they're subtracting, so we can add the opposite, however many opposites we need here. And then it's going to be just like we did with addition. So the denominator is the same. We're going to add the numerator together, and then after we do that, we'll see if we can simplify any further. So if you work that out in the numerator, that would be 6n minus 8, or 6n plus negative 8. So at this point, we're looking for a greatest common factor in the numerator and denominator, and we actually have in the numerator and denominator a 2 that we can factor out. If we can't factor it in both places, then we'll probably not mess with it because it's not going to help us simplify. So then the factors of 2 can cancel out. And if you want to put your parentheses up there, you can, and then that would be our final answer. We go over to part C. Similar story here, denominators are the same. Can add the opposites there. Doing a problem like this, you might notice with that denominator that that's a difference of squares. And so that seems a little fishy that they would give us a difference of squares denominators if it wasn't for the fact that we would be able to reduce with that. So if you wanted to, you could kind of make a gamble here that that's going to help us by factoring that difference of squares, and that's going to end up canceling. If you want to wait one more step because it's less writing to do q squared minus 4, you can just wait on that. But like I said, good chances that they did that for a reason, because that's going to cancel out somehow later. So with the numerator, that ends up as q plus 2 or 1q plus 2. And so actually we didn't even have to do anything with factoring anything out of the numerator. We already have these q plus 2 factors that we can cancel. And so that would be our answer, would just be 1 over q minus 2. So if we look at the lesson check, the problems we've done up to this point, we have just done problems that have the same denominators. So we're going to look at number 1 and 2 here. So number 1, we are adding. Always make sure you check that sign, because what's going to happen, we get to a set of questions or we get onto a test and the directions say add or subtract, and you accidentally do the wrong operation, then that's obviously going to change what your answer would have been. So our denominators are the same here, so we can add the numerators. So 4 plus 7 is 11. Denominator stays the same. So 11 over x minus 7. And then if we look at number 2, this is a subtraction problem. In this case, they only have some monomial in the numerator on the second fraction, so there's not quite as much happening here. You can add the opposite there. So then that would give us 4 over 2y plus 4. At this point, we're going to try to factor, if we can, in the denominator. You might notice there's a 2 we can factor out, and that would leave us with y plus 2, or 1y plus 2. In the numerator, technically, if you want to just leave it as a 4 and then think of reducing it by 2, you can. Or if you like it better, you can actually physically factor out a 2 and say that 4 is 2 times 2. And then we can reduce the numerator and denominator both by 2. And again, don't be tempted to try and reduce those 2's there. We have that force field around the denominator, that y plus 2, it's not, those are not factors. So unless you see another y plus 2, you can't cancel anything with that. And then one more problem we're going to look at. This is actually a problem that's in my book. You won't find it in your books. They're asking us to find this difference. This is maybe a little more interesting of a problem than that last one we just looked at. So once again, this one is they're subtracting. Notice the sign in between, subtracting. So subtracting means we're going to need to add the opposites here. Watch your signs. So then this would give us 5x minus 1 over 5x squared plus 9x minus 2. Since we have a trinomial here, again, put up your force fields if you want. Since we have a trinomial in the denominator, we still do have a chance that potentially we could get something to cancel out. In order for this to work, for us to be able to reduce this at all, we would need a 5x minus 1 factor in the denominator, and then it's just a matter of figuring out what goes in that other binomial. So in order to get this to work, we need 5x times x to get 5x squared. Negative times a positive is a negative, and then 1 times 2 is 2. And then we just got to check our middle term and see if this works or not. So that's 10x minus 1x is 9x, so that works. So what we may want to do, since we're going to be canceling out our whole numerator here, you might want to put a 1 in front of that, because we do need to have a numerator still. And that would be 1 over x plus 2. And again, if you want to put parentheses around the denominator, you can. There's really, with the 1 in the numerator, no temptation of trying to even reduce anything, so it's probably not even as big of a deal on that one.